Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome you all in lecture 14. Uh, Today, inshallah, we will basically cover a new example, which is the design of overhang beam and finding out the cutoff points. Okay. So you will see the example right on the screen. This is the overhang beam, and it is constructed from normal weight 3000 psi concrete, 60,000 psi reinforcement. Supports a factor dead load of 0.42 kPa. This is a dead load, and remember this is a factor load, and a factor live load of 3.4 kPa per foot. The cross section at the points of maximum positive and negative moments as given in figure this and this are shown. Okay, so the beam is designed, and it says that for maximum positive movement. Okay, for maximum positive movement, the cross section is this one, and for maximum negative movement, the cross section is this one. Okay, so now you see that the whole depth is 24 inches, and for positive reinforcement, you see that there are number 3 slabs at the rate of 10 inch center to center, 2 number 8 and 2 number 9, and similarly 2 number 8 and 2 number 8. That is the top here force. This is the overhang portion. First of all, they locate flexure cutoff points for positive moment reinforcement. Okay, so for positive moment reinforcement, they find out the uh, location of cutoff points. Okay, so the positive movement in span AB. Okay, it should be noted that the positive maximum movement will be in span AB. Is governed by the loading case in figure 830 from a free body size. Remember that there is some new information, and that new information is that you have to analyze this beam for different location of live load, and then you can see that where is the maximum positive movement. Okay, so what that is basically, they assume the live load on the AB span, you see, and dead load on the shorter overhang portion, and then they get the maximum positive movement, that is 283 foot, and maximum shear for positive movement is 46.7.5. So whenever you have more than one span and you have live load case, so we basically analyze the beam for various combination of live loads. Okay. At this live load basically 3.82 on this span, so, and we assume that dead load is there. We check out the positive movement. Then we place this live load on this span and live load on that span. Okay, and we check that what is the value of maximum positive movement. Similarly, we also check the negative movement. Okay, that if the live load is there and this dead load is there, so what will be the negative movement? Here you can see that this is 30 kPa live load. Sorry, the maximum negative movement is 30 kPa. But if we replace this live load there and dead load is there, you can see that live load will become increased. Okay. So basically, this is the case. If we do if we convert this live load, this dead load to this span, and this span, this load to this span, so what will be the maximum positive movement? It seems that, let's say this is kPa, two span, assuming that the spans are 25 foot. And if the grids first span is 25, the second span is 12. Okay, okay. So this is the case. Let us this is hinge. Okay, so we see that, let's say we place here the point 0.42 cap put, and we place there, okay, 3 3.4 cap put there. So in the case number one, 0.42 is there and live load is there. Now we just convert the live load there and the dead load is there, and we see that what will be the result. This is overhang. Now this is the elastic curve, and we see the moment diagram. So you can see that there is the maximum negative moment is present. Okay, this is the maximum uh, tension side. Okay, so this in this case there is total negative moment, and that is minus 244. There is no positive moment. Okay, so therefore you should need to analyze the beam for different loading cases. So here our maximum positive moment is what? The maximum positive moment exists for this loading case, and this minus 30 will be not the maximum negative moment. The maximum negative moment will be minus 244, and I think that will be given at the end, because this beam is analyzed for two types of loading. The one is the maximum positive moment and the other is that distance. Okay, you see there is minus 274 75 foot. This is the maximum negative moment. The beam is analyzed for a maximum negative moment, which will be this one, because you must know that in the live load case your live load vary, because it may happen that the whole live load comes here, okay, or it may happen that the whole live load is there. Okay, so you should need to determine the maximum case scenario. Okay. This is the maximum moment. This is the movement equation, okay, for the AB span. Yeah. 46 is the reaction and 3.82 is the live load. This is for AB span, not for BC span. Okay. This is the shear diagram. 46.5 kips is the maximum shear. Okay. And this is the shear equation. You see that this is the shear equation. You can write the shear equation for like okay, as you see that this is 46, okay, and if you have, this is the, and you consider, okay, so this is x, okay, your shear equation V will be at any point 46 minus loading, that is 3.84 or 3.4, sorry, into x, just only x, and your moment equation will be 46 into x minus 3.4 x squared divided by 2, which will be the moment equation, and this one, but just only for the span AB, clear? Span AB, not for span BC, clear? So after that they calculate A, because for positive, maximum positive movement, steel area is given, okay, that is 2 number 9 and 2 number 8 bar. So this A should be calculated. A will be uh, it should be remember that this calculation, this A is determined for 2 number 8 bar. Right? They say that if 2 number of bars is cut off, its mid span the beam has 2 number 9 plus 2 number 8 bar. The 2 number 8 bars will be cut off. The capacity of the remaining bars is calculated. Now 2 number 8 bar is cut off. Okay. So what will be the capacity if there are 2 bars, 2 number 9 bar present, okay, at cutoff points? So that determine the capacity, okay. 1 square inch is the cross-sectional area of number 9 bar. So your A will be this one, and phi mn, which is determined from this equation, will give you 176. Okay. Now you need to determine the location of 176 as we done in example 2, okay, and as well as in example 1, okay. So you just find out the location of this, you write the equation, okay, right there, you write this equation, compare this equation with phi mn, just put there 176, solve this equation for x, which becomes a quadratic equation, and after comparing that, you know this is the quadratic equation, and it's right here, okay. So you determine the x value, and the x value will be 19.66 and 4.6. So you just select this one. Okay, this one is not possible because the AB span is just only 25 feet. Okay, not 19.66 is not possible. And just near the maximum loading is just near the 176 will possible like there. Okay, not there. And this point, I think so, this point lies at a distance of 19.66. It may possible, clear? So basically, this 19.66 can be determined from SEF also. If you remove this loading, okay, mm, this span, there is 3.4 kept foot clear, and in this span there is 0.4. 42. So if we analyze, there is Yes, this is minus and this is positive. Okay, 250. Now you need to determine 176. 176. 176 will be at the distance of 176 will be at a distance of, you can say, moment 176. Yeah. Once it will be at the distance of 5.5, you know how much is that 283 gives you, and SAP gives you maximum moment 283, and this gives you, okay, 250. So there is a little bit difference, because there is a little bit difference there. I think so there will be something wrong. This should be equals to 280, 280, 285. Clear? If it is 2, it is 25. Okay, change the editor. Let's see. This is 12. Okay. This one, clear, clear. Assigning. This one equals to, okay. Assigning this one equals to ruler, and this one will be hinge. This one will be hinge. What will happen in the Z, chip chart? No. Spain, this is 25. Okay. This is 12. Yeah. Okay. Okay. Assigning this support to, this will be a ruler, and this will be hinge. There is uniform distributed load. This will be 0, and a uniformly distributed load of 3.82. This is 3.82. Okay, and this is distributed 0.22. Okay, this loading. Let's see. Model unit. Saving it. Overhang. Now it's comes out exactly 285. Okay, 284. So you see, where is the maximum moment? Clear? So where is the 174? Clear? So basically, if you screw, okay, you will get 176 at a distance of 4 point something around about. This is okay. 177, 170, round about 175, because you cannot exactly screw at 176. Okay, this is 4.69, round about 4.8 or 4.7. Okay, that will be the theoretical cutoff point. Clear? That will be the theoretical cutoff point. 4.68. You know, I will mention you 4.7, 4.8, 4.75 something. Okay. So the next point, I think so, at 19, the next 176 point will be at a distance of 19 point something. This is the 19.66. You can say the next value. Okay. So this means that the next 176 value will be at a distance of 19.66. Clear? These are theoretical cutoff points. Okay. They will be referred to as theoretical flexural cutoff points, E and F. It will be representing on a diagram letter E and F. These two are the theoretical cutoff points. Okay, at a distance of 4.68, and from this will be equal to 19.66. Clear? Now you need to determine the actual cutoff points. Okay, and you need to determine the LD. Okay, so in a similar fashion, by setting mu equals to 0, the flexural cutoff points G is found to be 24.4 foot from A, or 0.64 foot from uh, basically, you there is there is a there is a uh, G point, which is a point of inflection, and you must know to find out the location of this G. This G is basically, from the face of the support. This is the face of support, and remember that the face of support, you should know that it is measured from, there will be some width of the face of the support. You see this one, clear? That at the center of the beam, there is 49 caps. Okay, but at the face of the support there is 46.5 kips share. So at this point, this point, uh, the 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 moment will be zero. Okay, at this point the moment will be zero. Clear? So this G not lies on the support. It is some distance away from the support, and that distance is 0.64 roundabout. You see that there is a little bit uh, red portion present there. Okay, and their movement becomes zero. Let's see. Okay, you can see that there is movement equals to zero. You see, and then it start increasing. That is the negative movement. Clear? So this 0 point is basically lies at a distance of 24 feet from that support A. But if you subtract this distance from 25, you can get that this G point will be at a distance of you see that this point, this G, this is point G. Okay, their movement equals to zero. So this 0 point is basically lies at the distance of 0.264 from this, and from that it lies at a distance of 24 roundabout feet. Okay, so this is the point of inflection, and we have to provide special arrangement there. Okay, and those checks over there. Okay, so this point G is the inflection point. Clear? So they determine that distance. Okay, uh, how you can mathematically determine this distance? You need to just compare that equation which is written above this one, because as in a point of inflection, moment comes out to be zero. So you just assume zero here and you determine x. You get the x value will be 24 point something. Okay, 24, which is from support A, but from the from the right support, it will be lies from support B. It will be lies a distance of 0.64. Clear? Now computing the development. Okay. So you just need to find out the clear spacing. Clear spacing comes out to be 1.33, and your dia bar is 1. So clear spacing is justified because it is more than 1. And now you need. It says that the state of criteria is according to the SA code as well, and spacing criteria is also fulfilled. So this is case 1. Select the formula from table number 8.1. There will be 1.1 the reinforcement case will be 1, because, and for negative reinforcement you will take this value is 1.3. So as the reinforcement, the bottom reinforcement is there, not the top reinforcement. So therefore the site E will be 1, no coating, so 1, you know, and 20 lambda is 1 normal wet concrete clear. So I think this is not complicated. 54.8 multiplied diameter of the bar with this, you can get 54.8 inch. And for number 9 bars, LD will be 61.8 inch. This is for number 8, and this is for, so you need to select this value. You need to select the greater value. Okay. So 61.8 will be the development line. Clear? Locate the actual cutoff points for positive moment reinforcement. Now you see that that uh, that there is around about, you can say that this is 176 point. So the distance for this point from the face, it is 4 point something roundabout. Clear? So that distance is actual cutoff point 4.68. Now you need to, as you see that this is the support and that is the moment diagram. Clear? So from the support, okay, this is 176 and this is the theoretical cutoff point. So you need to extend the theoretical cutoff point towards the support, because it is the case of positive reinforcement. So you need to extend the theoretical cutoff points toward the support. For a distance of how much? This distance will be, this distance will be d or 12 dB. Clear? 12 dB. And similarly, you also need to check for the maximum movement. Okay, that if you are providing 4 bars, in which 2 number 8 and 2 number 9 bars that you are placing, so the bars must be continued to this side also and this side also for a distance of L. So you need that how much this distance will be, whether this distance will be available, okay, or not available. Clear? So just check that values. Clear? You know, it's saying here, okay. So they say the actual cutoff points are determined from the theoretical flexure cutoff points using rules stated earlier, because the location of the cutoffs G and D are affected by the locations of cutoffs E and F. The latter are established first, starting with F, because the beam is simply supported. It is not included in the ACI code listing of members that are susceptible to actions requiring structure. So first of all, they locate cutoff point F. Clear? At cutoff point F, you have only 2 bars, and that 2 number 8 bars are cut off and 2 number 9 bars are extended. So 2 number 8 bars are cut off. They must satisfy rules for anchorage, extension of bars into the supports, and effect of shear. So these 4 criteria are present there. Okay. So extension of bars into the supports. Extension of bars into the support. This means that you must need to extend the bar into the support. Okay, into the support. This means that this is your support and the bar is coming from this side. You need to extend this bar 6 inch into the support. Okay, one thing should be justified. So at least 1/3 of the positive moment reinforcement, but not less than 2 bars, must extend at least 6 inch into the support. You should extend 2 number 9 bars into each of the supports A and B. It must note in, okay, that both sides, if you have 4 bars there, so this is for simply supported beam, that you need that in the support, you need that there must be 1/3 of the positive steel area will be provided there, of the positive. This is the SA criteria. That the positive steel which is right there, its 1/3 portion must be entered there, should be inserted there. But if it give you 1 bar, okay, 1 bar, so the minimum criteria is 2 bars. It may be larger than more than 2, but minimum you need to insert 2 bars from the positive steel into the support. And this insertion should not be less than 6 inches. Both way. There is also. It must be minimum insertion will be equal to 6 inches. So in both support, these 2 bars is inserted for a distance of 6 inches. Clear? This is the first criteria. The second criteria, effect of shear. So for effect of shear, you need to extend the theoretical cutoff point toward the supports in case of positive reinforcement for a distance of d or 12 dB, whichever is better. So d is 21 inches and 12 dB is 1/4. So you select 21 inches. That may be around about 1.9 something. Okay. Therefore, the first trial position of the actual cutoff at 19.66 plus 1.79. Okay, that is 21.45 feet from the center of the support at A. Say 21 feet 6 inches. C point F dash in figure. Okay, this means that the theoretical cutoff point there is this theoretical cutoff point F. They first locating this theoretical cutoff point F, and then they will be look at this E, and then they will look at this point G. Okay, so you know here, okay, E and F is basically theoretical cutoff point. Okay, theoretical cutoff distance is 4.68, and theoretical cutoff point distance for this point is 19.66, and for G, which is the point of inflection, it occurs at a distance of 24.36. Okay, from that support, it is at a distance of 0.64. Now these are theoretical. We need to determine the actual cutoff points. Okay, so this F is theoretical and this F dash is now actual cutoff point. We need for shear effect to extend this F towards this support for a distance of 12 dB or D. So here the controlling criteria is D. So 1.7. So a distance now from the center of the point. Okay. From the center of the point equals to 21.6 inches. Okay. And now effect of shear anchorage. Anchorage criteria is that you check for development length. Okay. Bar must extend at least LD past the point of maximum bar stress. For the bars cut up at F dash, the maximum bar stress occurs near midspan at 12.18 foot from A. The distance from the point of maximum bar stress to the actual cutoff point is 21.5 minus 12.18 gives you 9.32. Okay. Basically, you see that it says that at the maximum point, as we are cutting 2 number 8 bars, these 2 number 8 bars from the maximum movement, it must be inserted for a distance of LD both ways. Yeah? So this criteria is fulfilled right here because you see that the distance available for the first theoretical cutoff point, that is this distance F dash. So F dash from the center of the point lies at a distance of 18 point something, where this distance is 18 point something, where that is 12.18. Mid or the maximum movement lies at the distance of 12.18 from A, and F dash lies at a distance of 21.5. So the total distance available, that is 9.32. Means that this point F dash from the center point lies a distance of 9 point something distance. and as you will calculate 9.32 feet. Okay, this f dash lies a distance of 9.32 foot from the center. Okay, and you know that LD is for number 8 bar is 54 inches. That is roundabout. Roundabouts comes out to be 5 feet. Okay, so as 9.32 is greater than LD, so the anchorage criteria for this actual cutoff point is fulfilled. Okay, next is cut up to number 8 bars at 21 foot 6 inches from A as shown point at dash. So that bar can be cut up at that point. Clear? Cut up G. Now this is the inflection point. Okay, this is the inflection point, and in inflection point, okay, you also make those 4 cases. Okay, these 3 cases. Okay, you need to check it for extension of bars. You need to check it this, and you need to check it this. Clear? So first of all, extension of bars into simple supports. At point of inflection, you also cut up the bars. So in step A, we stated the need to extend two number 9 bars 6 inches into support B. Okay. So that 2 bars will be extended. Okay. You can't cut it. Okay. This G dash is at 25 feet 6 inches. Okay. This G dash, clear? This G dash is, as you see that this G is 0.64 foot. You see there. This is from the center of the point, from the center of the support. It lies at a distance of 0.64. So just add, you know, what you just add. We stated the need to yes 6 inches. 6 inches. This the bars which is cutted at point G and continued those the bar which is continued at point of inflection must be inserted into the support for a distance of 6 inches. So add those 6 inches with the with the distance 24.36. That comes out to be, I think so, 24 point. It comes out to be 25 feet 6 inches. Yeah, it comes out to be 25 feet and 6 inches. There 6 inches will be added up with 24 feet. Okay, so 24 point, no, as we know that to the center of this support the distance is 25 feet. So if we add 76 inches with 25 feet, it comes out to be 25 feet and 6 inches, or you can say 25.5. Okay, so basically this 25 is comes out from that. Okay, because up to the center from the point A to point B there is 25 feet distance. So add 6 inches with 25 gives you this distance. Clear? Effects of shear. Because the cut off is at support, we do not need to extend the bars further. So because it says that this point G dash is it is into the support. Clear? You see that this G dash is into the support. You do not need to cut to extend the bars. Okay. And the next criteria is anchorage criteria. Bars must extend at least LD past actual cutoff of adjacent bars. LD for number 9 bars 61 point this much inches. This is LD for number 9. That's equals to 5.15. Distance from a dash to G dash is 25 feet. Now you check this distance. A dash distance from F dash, G dash is how much? 1 feet 8 inches is this distance. Clear? So 25, this point G dash lies a distance of 25 feet 6 inches, and this F dash lies a distance of 21 feet 6 inches. So subtract these two values, you will get 4 feet. Clear? So the distance between these F dash and G dash is 4 feet. Bar does not extend LD. Therefore, extend the bars to 21.5 feet plus 5.15, say 26 foot and 4 inches. This means that this continued bar must extend from this actual cutoff point for a distance of LD. Clear? You see that. Now, when they check, you know that I will make the sketch again. There is a little bit confusing things. Clear? You know that the G distance, G dash distance, clear? It is roundabout, at a distance of 25.5 feet, clear? And you also know that actual cutoff point F dash, okay, that is the actual cutoff point. It lies at a distance of 21.5 feet, clear from this support. Now, code or ACI code criteria says that the distance between these two cutoff points must be equal to LD. And once we calculate this LD, means 25.5 minus 21.5, it comes out to be 4 feet. Which is less than the LD distance. LD distance for number 9 bar is roundabout, which is calculated. It comes out to be, I think so, 54.61 inches roundabout. Where we calculate this one, 61.8 inches, which is roundabout 5.5 feet. Clear? 5.5 feet. Okay, roundabout comes out to be 5.5 feet. Okay. So what ACI code says? ACI code says that this G dash must extend from this actual cutoff point for a distance of LD. So therefore, we extend this point G. Clear? We extend this point G for a distance of LD. Clear? For a distance of LD. So add, you add 21.5 plus LD. That will give you the theoretical cutoff point of G dash. Clear? So basically, you see here, the G dash must lies at a distance of LD. Okay, LD. So what they did, 5.17. 5.17 is basically 61 point something inches. Clear? This much. So you see, this is 61 point. It comes out to be 5.16, or you can say that it comes out to be distance from F dash to G dash, 21 point this minus this one, 4 feet. Okay, that is not equals to 5.15. So bar does not extend LD. Therefore, extend the bars 21.5 plus 5.15. It comes out to be 26.65, say 26 feet and 8 inches. Now, the distance of G dash from the point A comes out to be this much distance, 26 foot at 8 inches. Clear? So these are the rules that at point of inflection, okay, at point of inflection, these two bars, as these are continuous bars, so these bars must be continued for away to the right side. Okay, or if it's there, so then it's to the left side. So it must be extended first of all you should check it for shear. For shear criteria, it must be extended for a distance of d or 12 dB. But as the point is at support, you don't need, because the effect of shear is less. Okay, so they ignore it. Then you need to extend this point 6 inches into the supports. So you extend it for a distance of 6 inches from the center of the support. Clear? And from the center, so up to the center distance is 25 feet. You just add 6 inches with 25 gives you 25 feet point 6 inches or 6 inches. Then the code criteria says that the steel which is extended from the point of inflection must be lies at a distance of this actual cutoff point, the distance of LD. So once we check, we determine that this G dash lies the distance of 4 feet from F dash, and as the development length is 5.17 or 15 foot, so as the distance is less, so therefore we extend this G dash from F dash for a distance of 5.17. So the total distance of G dash comes out from the point of this. Just add a distance of 5.17 with the distance of the dash from that support, which comes out to be 26 feet 8 inches. Clear? Now this criteria is fulfilled. As well, you need to check, this criteria. This criteria will be checked out at inflection point. Okay, this is you can say this is a one of valuable criteria. You must need to check it at point of inflection. The point of inflection is 0.64 feet from the support. Okay, you see here that this point of inflection G is a distance of 0.64 feet. Okay, and at this point VU is 46.5 kips. Okay, that you need to determine that how much shear at this point, 0.64, and that are determined here. Okay, that are determined here. This one. Okay, this shear is a distance of 0.64, which is 46.5. Clear? And then you know Mn. Mn is 0.64, that is 176. Okay, 176 multiplied by 12, converting foot into inches, dividing by 0.9 to convert it into 5 Mn. Okay, so 5 Mn value will be 2350. Okay, this Mn should be converted with phi value, and phi value you need to divide it with 0.9. Clear? So here you can see that 2350 divided by the shear plus extra length, that is you need to provide that length to this side, that is here it takes L equals to, I think so, consider it to be 12 dB or 12 dB. Okay, although we consider this LA equals to 6 inches, but here the author considered it for a distance D or 12 dB. So 21.5 inch is added extra. Clear? So you see this total comes out to be 72 inches, which is more than 61 inches LD. Clear? So this criteria, that is 61 inches. So as this is greater than, so this criteria is also satisfied. But remember, your now G dash point will be lies at the distance of 27.7 inches. Therefore, L at 21.5 inches. Now the exact location of G dash, L a larger, but not more than the actual extension, the bar past the point of inflection. Therefore, so cut off 2 number 9 bars 1 foot 8 inches from B, shown as point G dash. Okay. Clear? This G dash is now at a distance of 1 foot 8 inches. That it lies a distance of 26 feet and 8 inches. Clear? 26 feet and 8 inches. You need to extend, this G dash for a distance of uh, 72 inches. No, not for 72 inches. You need to extend this G dash from this point of inflection for a distance of LA. LA is how much? 21 point something inches. So I think so that comes out to be 1.794. So if you add 1.7, uh, if you add 24.36 with 1.79 inches, 24.36 plus 1.79 comes out to be 26.15. And as we calculated that this distance will be, this G dash should be uh, from development length criteria, that it should be lies at a distance of 26.8. So 26.8 is more than 24.26.15. So therefore, ignoring this criteria and go for the maximum value. That is, 8 divided by 12 gives you 0.66. So plus with the uh, 26 gives you 26.66, and subtracting 25, okay, gives you 1.66. So this means that 0.66 is equals to 8 inches. So point G lies to the right of the center of the support for a distance of 1 feet and 8 inches. Yeah? 1 feet and 8 inches, and you see there. Yeah. So okay, this basically means that the point of from the point of inflection, okay, or from the point of inflection, from that criteria, MN criteria, VU plus LA, it says that the bar must extend it for a distance of LA. So LA is basically 1.79, and as this point of inflection is 24.36. So if you add this LA with this distance, it's give you this point at a distance of 26.15. Clear? And as we determine the exact location of G dash, okay, that is G dash, and we determine the location of G dash from the support point, that is lies at a distance of 26.66. Okay, so this one is greater than this one, so ignore this one and adopt this value. So as there is support center, so how much this distance will be? Okay, how much this distance will be? The support distance from the center of the other support is 25 feet. Clear? And this point G dash lies a distance of 26 feet. So just subtract 25 feet from 26.66 gives you this distance, which comes out to be, this distance comes out to be 1 feet and 8 inches. Clear? So this is the basic, the basics behind this 1 foot and 8 inch. Clear? So now they're locating the next cutoff point E, which is to the right of the maximum point. Clear? So basically this point E dash. So first of all, you must check that this point E must be lies the distance of LD. First criteria. The second criteria is that this theoretical cutoff point should be extended towards the support for a distance of 12 dB or dB, that is 1.79. Okay. Now if you extend this E to E dash 1.79, this distance is 4 point something, okay, 4.68. Okay. Have Okay, this distance is 4.68, so it will be extended, you know, for a distance of this is the actual theoretical cutoff point for a distance of 12 dB or a dB. Now that distance is 1.79, so extend this. Now this distance will be reduced. Okay, so this distance is how much right now? 4.68 minus this distance, 4.68 minus 1.79. Yeah. Now this distance will be reduced, and criteria says that this E dash from the maximum, this maximum point is 12 point something. Okay, so you need to subtract this from the center. You know, you need to subtract this is, I think so, 12 point something. Clear? And now this distance is comes out to be 4.6 at 4.68 minus 1.779. Okay, 79 comes out to be 2.89. This comes out to be 2.89. Now you need to subtract from the center distance this distance. This 2.89 gives you this distance, and you check that whether this distance is greater than LD or not. If it is greater than LD, so okay, there is no developmental length problem, increase problem, and if it is less than, you need to extend it. Okay, so therefore they did that calculation for E. Effects of shear, they extended for 1.7. Okay, 2.89 is comes out. Increase positive, you know, that is 54.8 inches development length, and that will be okay, because that distance will be more than, you know, this distance is more than LD, right here. Okay, and similarly you need to check this distance right now whether it is equals to LD or not. If it is equals to LD or greater than LD, then okay. If it is less than LD, so either you can change the size of bar, either you can provide the hooks, or either you can't cut up the bars. So they're checking. Okay, this point is crucial. Clear? Mm, okay. Cut up two number 8 bars at 2 foot 10 inches from A. Clear? So point E dash and note that this is changed later. We will check it later. You know, this 2 feet and 9 inches you write, see there, that will not enough because it is less than from development length. So in later stages we will check it whether it is fulfill the criteria or not. So here they leave it at this point E dash. Okay. So in later stage inshallah we will deal with it. They also check, you know, where, okay, now they calculating the cutoff distance D. Clear? They calculating the cutoff distance D. Okay, the cutoff distance D, this one. Okay, okay, so let's see. Two number 8 bars are cut off. We must consider the extension into a support, extension beyond the cutoff point E dash, and development of bars at a simple support using extension into a simple support. You know, you must extend the bar 6 inch into the support. Clear? Bars must extend LD from the actual cutoff point E dash, where LD is 61.8 inches for number 9 bar, and the maximum possible length available to you, that is uh, you know, 2 foot 10 inches, 2 feet which I calculated it, and 6 inch is the extension into the support, so 40 inches. Because this is less than LD, we must either extend the end of the beam, hook the ends of the bar, or use smaller bars, or eliminate the cutoff point dash. We shall do the latter. Therefore extend all 4 bars 6 inches past support. Okay, you do not need to cut the bars dash, clear? Because here the development length criteria is not satisfied. So either change the diameter of bar, either provide a hook, or either extend all the bar. So that they adopt that extend all the bar, because the distance from the this 6 inches should be added with this distance. Okay, 6 inches will be added with that distance. So you see with the 2.89 clear. With 2.89, if you add that 6 inches, it comes out to be 14 inches. If you plus 6 inches, it comes out to be 14 inches. And 14 inches is less than LD, that is 61 inches. So you need to extend all the bars to the supports. Now we deal with this in later stages as well. Clear? Now they also check, because this is a simple support, you need to check this criteria also as well, because the moment at the supports comes out to be 0. Okay, so at the moment at the supports come out to be 0, okay, you need to check that for this criteria. So you need to determine the mn is 170, 176. Okay, and divide that by 0.9, multiply with 1.3, gives you, and this is your share. Okay, this is your share, that is 46 point. If you comes to the share diagram, you see that 46.5 is the share at the simple support at this point A, and the mn will be 176. Okay, now what they did basically, they calculate A 3.5 at 2 number 9 bars, and this is 70 7.02 inches. Mn is calculated, that is 3860 kef inch. Now what they basically did there. At a distance LD, they determine the Mn. Okay, at a distance LD, they determine the Mn value. Clear? So as you have two number 9 bars, so if you have two number 9 bars will give you where? Okay, there is no hints at this point. Okay, so the time is 3.58 square inches multiplied by 60 gives you 7.02. Okay, and Mn is calculated. Mn comes out to be this one. La here for extension from the point of 0 point, because diagram starts like there, and this is the point of inflection. The bar is now, this is the center line of bar, this is the support. Okay, the bar is extended from the center line of the bar for a distance of 6 inches. So La comes out to be 6 inches here. Okay, and at the first case it is equals to dr 12 dB. Now you cannot take it equals to dr 12 dB, because there is not enough space. There is only 6 inches available. Clear? So they check this criteria at 114 inches. You must need to extend the bar. You must need to extend the bar from this E dash 114 inches, and there is not enough space, so you need to extend all the bars. That is the simple way, because this exceeds LD. So development at the simple support is satisfied. The actual cutoff points are illustrated in figure, and this criteria is now satisfied. Okay, because it's 114 is more than LD. Okay, 114 is more than LD, and basically this 3.5 X comes out from two number 9 bars. Clear? Two number 9 bars, and it was checked for a distance of LD. Clear? For a distance of LD, or you can say this distance is equals to A. Okay, equals to A. You consider this distance equals to LD. Okay, so at a distance A from the support, the moment capacity will be, when they check, it comes out to be 3860. Clear? And now they multiply 1.3. Okay, 1.3 with this term. Okay, comes out to be this one, and divide by this, comes out 114, which is greater than. So this criteria is okay. Okay, so here what they did basically, they extend all the bars to this point. There, and you must know that two number 9 bars not giving you 3.5. It must be remembered. Basically this area is the sum of two number 9 bar plus two number 8 bar. Okay, this is the sum of two number 9 bar and two number 8 bar, and you must need to select this area from tables, which is right at the end of the pages of this book. Clear? Because if you actually calculate it, it doesn't give you this value. You need to take, because there is a rounding effect. So if you are interested to get the actual 3.58, you need to go to the tables at the end of this book and select that how much area two number 9 bars gives you and two number 8 bars. Adding both those area, it will give you 3.58. Why we take this 3.58? We don't cut the bars there, because we are extended all 4 bars into this support. We don't cutting the bar, because the cutting criteria for LD is not satisfied. Okay, so if 4 bars are there, so how much movement will be achieved? Okay, how much movement will be achieved at a distance of LD? So they determine basically that moment capacity, and then they check that LD. Okay, so there will be no cutoff bars at point E dash. Okay, you extend all the bars. Okay, after that, the rest of calculation is now for negative reinforcement. Okay, so inshallah we stop there, and we further continue lecture 15 beyond this point 4. Okay, so up to this point, you have any question, any doubts, you may ask.